All right, let's dive in. In this explainer, we're going to trace the invisible journey of a single click, from your finger, across oceans, to servers on the other side of the world, and all the way back again. And it all happens in the blink of an eye. So, let's follow the data.
I mean, think about it. You type in a website, you hit go, and poof, like magic, a web page just appears. But it's not magic. Not at all. It's this incredible, super high-speed journey. So what is really going on in that split second? To really get what's happening, we have to start at the very beginning, with the most basic building block of the entire internet, the network. Every single thing you do online, it all starts right here.
You know, at its core, a network is actually way simpler than you might think. Just look at this diagram. It's really just a bunch of devices that are all connected to each other. Could be computers in an office, your phone and laptop at home, whatever. They're all linked up so they can share stuff. It's basically a digital neighborhood.
So why do we even bother connecting all this stuff? Well, it's all about one word, sharing, right? Instead of every single computer needing its own printer, a network lets them all use the same one. It lets us share files, use the same software, and of course, share that one crucial connection out to the internet. It just makes everything way more efficient.
So here's the first kind of surprising thing. Your clicks journey doesn't immediately shoot out into the wild. Nope, it starts small. It starts right there in your own home or your office, on what we call your local network. And this right here, this shows you the scale perfectly. On the left, you've got a LAN. That's a local area network. Think of that as your house. It's small, it's contained, you're in charge of it. But on the right, that's a WAN, a wide area network. That's the internet itself, this massive web that connects millions and millions of little LANs just like yours from all over the planet.
Okay, but for any of these devices to actually talk to each other, even inside your own little house, they need to know two things: who they are and where they are. They need addresses, just like sending a letter through the mail.
First up, every single device has what's called a MAC address. The best way to think about this is like a fingerprint or a serial number. It's permanent, it's totally unique to that one piece of hardware, and it never ever changes. It's the answer to the question, who am I?
And then you have an IP address. Now, if the MAC address is your device's fingerprint, the IP address is more like your mailing address. It's not permanent. It can change every time you connect to a different Wi-Fi network. It's not about what the device is, it's about where it is on the network right now.
So let's just make this crystal clear, because it's really important. The MAC address is who you are, your device's permanent physical identity. The IP address is where you are, your temporary logical location. You absolutely need both to send and receive anything online.
Okay, so our click has its addresses, it knows who it is and where it is, and it's ready to leave the nest, your local network. Now comes the giant leap out into the big, wide world, the internet itself.
You know, we talk about the cloud all the time, which makes the internet sound, I don't know, kind of floaty and wireless. But the truth is, the internet is a very, very physical thing. Your click is about to race through these massive bundles of fiber optic cables that are laid on the bottom of the ocean, connecting whole continents at almost the speed of light.
But how? How does your tiny little packet of data, your single click, find its way through this gigantic global maze without getting completely lost? Well, it needs a map. And even more importantly, it needs to follow the rules of the road.
And those rules are called protocols. And really, all a protocol is a shared language. It's an agreement. For a computer in Tokyo to be able to understand a computer in Toronto, they both have to agree to speak the same language and follow the same rules. That's a protocol.
Now, the main language of the internet is called TCP/IP, and the best way to think about it is like a digital post office. First, your browser writes the letter. That's the request. Then, TCP chops that letter up into a bunch of smaller, numbered packages. Next, the IP part slaps a mailing address on each one of those packages. And finally, they get sent out over the physical wires ready for their journey.
Now, for those IP addresses to work, every device needs a unique one. The original system, which we call IPv4, had about 4.3 billion possible addresses. And back then, people thought, that's it. That's basically an infinite number. We are never going to run out.
Yeah, well, we ran out, so we had to upgrade. And this is the number of addresses available with the new system, IPv6. That's 340 times undecadillion. It's a number so mind-bogglingly huge that you could give an IP address to every single atom on the surface of the Earth and still have plenty left over. So yeah, we are not running out of addresses again.
So, by following all those rules and using that unique address, our click has successfully crossed the globe. Now let's see what happens when it gets to where it's going, and what the real big picture takeaway is from all this.
So your little package of data arrives at the destination server. The server reads the request, finds the web page you asked for, and then sends that web page all the way back to you following the exact same rules, the exact same TCP/IP language. And this entire round trip happens in milliseconds. It's incredible.
And that really gets to the most important takeaway here. The internet isn't one single thing. It's exactly what this quote says, a global mesh of interconnected networks. It's thousands upon thousands of separate networks, all agreeing to speak the same language, working together in this massive global team effort.
Which brings up a really fascinating final question. If it's this huge globe-spanning thing that connects all of us, who's actually in charge? I mean, who owns the internet?
And the answer is nobody. And kinda everybody. It's weird, right? There's no CEO of the internet. Instead, you have thousands of different companies, ISPs, tech companies, even governments, that own all the physical pieces, the cables, the servers, the routers, and the whole thing is coordinated by a handful of global nonprofits. Groups like ICANN manage all the names and numbers, kind of like a global phone book, and the IETF helps develop the protocols, that shared language we talked about. It's this amazing, decentralized collaboration that, against all odds, actually works and connects our entire world.